Hello everyone, we are the A team. In this video, we will provide a method to recycle copper from printed circuit board, which is one of the most valuable part of the e-waste. It is estimated that 65.4 million tons of e-waste will be generated in 2017. If we just landfill or incinerate them, there will be some environmental problems. Instead, if we recycle them, we can recycle many valuable parts from them. Since the traditional e-waste recycling method process can cause healthy problems and they are very low efficient, we can use more advanced method to recycle them. Among the metals, we can see in this table that copper has the highest concentration according to the weight. We have analyzed three relatively advanced methods to recycle copper, and we used a weighted decision matrix to evaluate all these three methods. We used 5 criteria to analyze the goals, and we can see from this table that fungal leaching got the highest score, and we will analyze how the details later.
I will quantify the resource efficiency of fungal leaching here. Microorganisms such as bacteria and fungi have been used to extract metal from ore. Compared to conventional metal extraction technology, the fungal leaching has been considered as an environmentally friendly technology. In order to quantify the efficiency, some previous research concerning the fungal leaching is used. As we mentioned before, copper, which has the highest percentage in the PCB, is used to quantify the resource efficiency. Also, I tried to calculate the monthly revenue by using copper unit price here. Since extraction efficiency is highly affected by the leaching condition, we decide the 6 leaching condition parameter with the optimized range, and also we decide the type of the fungi having the highest recovery rate from the experimental scale reference. So in order to quantify the resource efficiency, we use Purdue surplus as a case study. Some of team members visit the surplus and we asked the amount of PCB delivered from the Purdue. And they said they receive 2 tons of all kind of used stuff every day. Based on this information, we assume that 1 ton of PCB is delivered to the surplus every month. If we apply the weight concentration and fungal leaching process here, the amount of copper recovered from the process is about 0.119 tons. Based on this value, the resource recovery efficiency for every 1 ton of wasted PCB is shown in the slide. Monthly revenue also can be calculated by using copper unit cost. So fungal leaching also has limitation and challenge since it is microorganism process. It is very slow process which can cause less profit, and byproduct of the metabolism and organic acid from the process can cause environmental problem. For the last, it is not easy to manage fungal growth rate since it is a live things.
Okay, I'd like to talk about the assessment of economics and environments. The graph shows that in past decades, the e-waste recycle ratio have been increased in the United States, and in 2030, the ratio come up to about 40%. There is still 60% for recycling. And this picture shows the location of the e-waste recycle facility in America. We can see only one facility located around Lafayette. So when we consider about the full-scale application, the source of the e-waste should be concerned. So for the next case, we just assume that we have enough e-waste for treating, and in one full-scale case study, the cost will be $3 per kilogram copper recovered, and the price is around $5 per kilogram. So the profit is not relatively high enough. So if we want to maximum the profit, we can recover all available metal in leaching solution, which will work better for our application. And when we consider about the environment part, about 0.6 tons of carbon dioxide will emission for each 1 ton waste treat. And we also need to concern about the unbiodegradable organic matters, which could be the potential issue in the predict future if we just leave it in the environment.
In this part, I will talk about problems for larger scale usage for fungal leaching. First is fungal cultivation. In the full-scale unit, the fungi will be planted in high density and the contagions caused by virus can easily lead to mass deaths of fungi. When the quality becomes large, it's also hard to monitor the nutrition situation for all the fungi. Another problem is pollution. The high concentrated phosphate and organic acid are not only most important nutrition source and valuable product of fungi separately, they can also become pollution if not treated suitably. In the following part, I'm going to talk about the potential global application from the view of 3 countries below. First is China. As we can see from the picture on the right, China produces a huge amount of electrical waste and it will approach the portion of 50% of the whole world in 2020. However, from the picture on the left, the whole world is still treating China as their recycling factory. So, how is the situation of Chinese recycling system? Let's watch a video.
In China's Guangdong province, recycling electronic waste, or e-waste, is a multi-million-dollar business. Some 80% of the people who live in the city of Guiyu earn a living by ripping apart old electronics, especially mobile phones and computers, and salvaging valuable components to sell on the lucrative e-waste black market. But the communication revolution brought about by these high-tech products also has a darker side.
So what is the darker side? Here it is, using 19th century's technique, living on a trash mountain. So from above, we can see that China's urgent need is to build a regulated and efficient waste treatment system. As an advanced and newly born method, fungal leaching may not be the best choice for Chinese government and companies in the near future. However, we are optimal to the situation afterwards. Now let's go to Korea and EU. Both of them are developed, so we can see a relatively mature system could be summarized below. In the consumption part, law and regulations stipulate the duty for producers and citizens to recycle. In the product part, the design and produce procedure need to be eco-friendly. A benign circle has hence been constructed. We can then conclude that these 2 countries with highly developed system will also be interested in new technologies development, and actually they do. As an eco-friendly approach, we think fungal leaching has a chance there.
Okay, so now we want to know if the fungal leaching mechanism is feasible and applicable. Looking at the costs and benefits of the economic value, we might see that the fungal leaching process has the highest cost among the other methods that we have considered before. This cost that we calculated is the initial cost including the setup costs, tools, equipments, and the biological and chemical resources, assuming that we are recovering 1 ton of PCB. However, in the long run, bioleaching will be more advantageous comparing to the chemical process because they took less energy and we can always culture the microorganism without having to purchase it every time. Now, we want to look at the total profit we can generate by using each method to recover PCB. As we can see, fungal leaching process is the most beneficial among others. Besides it has cost few amount of energy to process and it is environmental friendly, recent research shown that the fungal leaching can recover other metal than copper such as gold, lead, zinc, iron, and other metal components that cannot be processed by bacterial leaching. Another benefit of fungal leaching comparing to bacterial leaching is that it can process a copper-containing material that cannot be processed using bacteria. So this method can basically decompose more metallic part of PCBs and thus will reduce the pollution from PCB disposal. Now, we want to look at the feasibility of fungal leaching. There has been several laboratory testing showing a successful application of fungal leaching and shows that it is highly beneficial comparing to other methods. However, there hasn't been any industrial scale application of fungal leaching yet.
and due to several reasons, it is hard to apply it in the large scale. But in order to make it applicable, we have to meet these conditions. First, there has to be a lot of organic carbon sources, as fungal leaching needs a lot of carbon source to grow. And then for a society requirement, it needs in-depth knowledge and familiarity of handling fungi by hydrometallurgists, and also development of method of catalyst is needed to speed up the slow process of fungal leaching, because it is very slow comparing to other method. And also the improvement of knowledge concerning genetic approaches is necessary. And that will conclude our presentation about the fungal leaching method. Thank you very much.